It is fairly common knowledge that the universe is expanding, and if you don't know that, you do now. Everything in the universe is constantly getting farther apart from everything else in the universe. But there's no center point of expansion, and there's nothing for it to expand into because everything's just getting farther apart. Now, as far as we know as humans, the universe is both infinite and expanding. So it's infinite in all directions and it's getting stretched out. Now, this is a concept that a lot of people struggle to grasp, because if everything's getting farther apart, where does the extra space come from? Well, the thing is, there is no extra space needed because the universe is infinite. Now, this is a crazy concept to be able to wrap your head around, and I can't even do it, and most people can't. And at some point, you just have to step back and realize that the universe is going to be beyond your understanding. But there's a pretty simple way that scientists figured out that the universe is expanding in the first place. But before we get to that, I want to clarify that the universe is not expanding outward from a single point, because everything is getting farther apart, and because the universe isn't relative to anything, then it can't have a point that stays in one place, because everything is moving away, and so depending on where you measure from, every point in the universe is the center point of expansion. Imagine it like this. You blow up a balloon slightly, and you draw a bunch of stars or galaxies or whatever you want them to be all over it. Then you start to inflate the balloon. Each dot that you drew on the balloon gets farther from all the other dots, but there's no one dot that stays in one place. This is how the universe works, but in 3 dimensions, which is why we need a 4th dimension, which is time, but that's not my area of expertise, and we can talk about that in a different video. If you're gonna take one thing away from what I just said, it's that everything in the universe is getting farther apart from everything else. Now we can take a moment to explain why we know the universe is expanding, and I promise this will make sense, but at first you might be a little bit confused. The Doppler effect is an effect that changes waves when their emission sources are moving. To put that in a simpler way, if I'm moving a speaker that's playing a frequency towards me, the waves are going to be compressed. And if I move the speaker away from me, the waves are going to become expanded and will grow farther apart. Now, you can't really observe this if you're holding a speaker in your hand, but if you have something like a drone, you can experience this if you just fly past yourself at pretty high speed. As the drone comes towards you, it's a pretty high-pitched noise, but once it passes you, the pitch of the whine of the rotors becomes lower pitched. The motors aren't working any harder or less hard depending on if it's coming towards you or away from you. This is merely your perception of the sound. This is also experienced when emergency vehicles are passing. If you're stopped on the side of the road and an ambulance drives by, as it comes towards you, the sound of the siren is higher pitched. But once it passes and goes away from you, it is lower pitched. This again is because of the Doppler effect. When something is coming towards you, the waves are compressed relative to you, the person who's hearing the sound. Now, if you were in the cab of the ambulance, you would hear the same pitch because you are not moving relative to the sound. Once the ambulance passes, the frequency becomes lower because the ambulance is moving away from you at such speed that it can alter the frequency enough for you to hear. Now, the same concept can be applied to light. So if something is moving away from you and shining a light, if it's moving away from you, it produces a red shifted image. If it's moving towards you, it produces a blue shifted image. Now, the reason it's these colors is because shorter wavelengths are blue, and if something is moving towards you and emitting a wave, the wavelength is shorter than what was produced. If it's moving away from you, it is producing the same wavelength, but you perceive the wavelength as longer. Now, we can observe the Doppler effect in stars as our planet orbits the sun. On one side of the orbit, we're coming towards the star, and so it's blue shifted, but on the other side, we can see that the star has been red shifted because we're moving away from it. Now, the difference is minimal, but with highly advanced technology and super expensive scientific equipment that I cannot afford, you can observe the difference in the color of the star that you're observing. And given this, you can actually determine how far away the star is. But that's not what we're talking about right now. Right now, we're talking about the stars that are on the edge of the observable universe. These are the stars that are so far away that it has taken basically the entire duration of time of the universe to be able to have the light reach us. Now, the James Webb Space Telescope took a picture of the farthest star ever recorded, which is 12.9 billion light years away. This star was taken with the James Webb Space Telescope, like I just said, but all of the instruments on JWST are infrared. This means that they are observing light that is further red-shifted than blue-shifted, and we can't necessarily see all of that light. But stars emit visible light, right? Well, yes, they usually do, but this star is moving away from us so incredibly quickly that the star is red-shifted so much that we can't see it with a normal telescope and we have to use infrared. And even in the color-corrected image for humans to see, the star appears red in the picture. Now, this redshift can only mean one thing. This star is traveling away from us at immense speeds. Now, this has been proven before this image was taken, but as of now, I'm going to use this image as an example. This is the farthest star away from us ever observed. This means that the star was redshifted, but it also can be used to prove that the universe itself is expanding. Imagine it like this. We are the Earth here at the center of expansion. Now, of course, we're not at the center of expansion, but we seem to be because of the way that we observe the universe. Now, imagine three stars, one that's relatively close, one that's a medium distance, and one that's pretty far away. So if we believe that the universe is expanding, we can use this information to test the hypothesis. So if I expand the universe like this, the first star only gets a little bit further away, even though it expands at the same ratio as the other two stars. This star got a lot farther away. It moved about 3 feet in the time that I moved back. This one moved about 1.5, and the other one moved maybe 6 inches, which means that this star got Doppler shifted to red a lot more than this one in the middle and the yellow one over there. Now, this has actually been observed in the real world, because the furthest away stars in the universe have been noted to be red-shifted as opposed to some of the closer stars. So the closest stars to us on Earth are not as red-shifted as the farthest away stars, which means that the universe is expanding, and we learned this just by working backwards from our hypothesis. Now, if this video did not make any sense to you, I'm terribly sorry. Let me know in the comments and I can make another video explaining what you didn't understand. But hopefully it did make sense. If you enjoyed the video, you can subscribe if you want. There are other videos right here and here. Thanks for watching.